Hello everyone, hope you're doing well. Today in this video I will explain chapter 1, function and their graphs, lesson 3 part E, domain and the range of the piecewise and sine, cosine, tangent function. Domain and the range of the piecewise function. Piecewise function, a function that consists more than one function defined at specific interval, like fx equal x minus 2 when x is less than 0, x plus 3 when x is bigger or equal to 0, fx equal to x squared plus 1 x less than 0, absolute value of x minus 2 when x is bigger or equal to 0. The domain of such a function is equal to the union of all intervals. Example number 1. Find the domain and the range of the function fx equal 1 minus x when x is less than 1 and square root of x minus 1 when x is bigger or equal to 1. As you can see that the number 1 supply this function in two parts. The first one is defined at x less than 1. And the second one is a part square root of x minus 1, which is defined at bigger or equal to the. Therefore, the domain of the function is all real number. When x is less than 1, then the 1 minus x is bigger than 0. Take any number less than 1, you can see that 1 minus x is bigger than 0. For example, if we take a 0, then 1 minus 0 is 1. 1 is bigger than 0. If we take minus 1, then 1 minus minus 1, that means 1 plus 1, it's 2. 2 is bigger than 0. Therefore, when x is less than 1, then 1 minus x is bigger than 0. And when x is bigger or equal to 1, then value of square root of x minus 1 is bigger or equal to 0. If we take 1, 1 minus 1 is 0. Therefore, it's equal to 0. And if we take 2, 2 minus 1 is 1, square root of 1 is 1, therefore 1 is bigger than 0. That means the range is a positive number, or begin from 0 to the positive infinity. Example number 2. Find the domain and the range of the function fx equal 3 minus x when x is less than 3 and square root of x minus 3 when x is bigger or equal to 3. Find the domain and the range of the function fx equal 3 minus x when x is less than 3 and square root of x minus 3 when x is bigger or equal to 3. And now pause the video. Try to solve the example like the first example. See you understand it, the solution or not. And to make sure of the solution, play the video again and look at the solution. Number 3 supplies the function in two parts. The first part is 3 minus x is defined it at x is less than 3. and the part square root of x minus 3 is defined at x is bigger or equal to 3. Therefore, when we drew the graph, you can see that the domain is real number, or from minus infinity to the positive infinity. When the x is less than 3, 3 minus x is bigger than 0. You can take a number. If you take 0, you can see that 3 minus x equal to 3. 3 is bigger than 0. And if we take minus 1, 3 minus x become 3 plus 1, it's 4. 4 is bigger than 0. Whatever the value of x is less than 3, then 3 minus x is bigger than 0. And whatever the value of x is bigger or equal 3, the value of square root of x minus 3 is bigger than 0. If you take 3, you can see 3 minus 3 is 0, then it is equal to 0. If you take 4, 4 minus 3 is 1, square root of 1 is 1, 1 is bigger than 0. Therefore, the range starts from 0 to the positive infinity. Example number 3. Find the domain and the range of the function f(x) equal absolute value of x plus 1 when x is less than 1, minus x plus 1 when x bigger or equal to 1. As you can see that the number 1 supply this function in two parts. The first part is defined at x is less than 1, which is absolute value of x plus 1. And the second part is minus x plus 1 when x is bigger or equal to 1 is defined. The domain is all real number. When x is bigger or equal to 1, then minus x plus 1 is less than 0 or equal to 0. If you take 1, it becomes minus 1 plus 1, which is equal to 0, is equal. And if we take 2, minus 2 plus 1 is minus 1. Minus 1 is less than 0. There, whatever the value of x is bigger than or equal to 0, then the value of minus x plus 1 is less than or equal to 0. Whatever the value of x is less than 1, then absolute value of x plus 1 is bigger than 1. If we take 0, 0 plus 1 is 1, 1 is equal to 1. Therefore, the range is began from minus infinity to 0 and from 1 to the positive infinity. Or we can say that the range is all real number except the interval, open interval 0, 1. Example number 4. Use the graph below. Find the domain and the range of the function f(x). The function, this part of this function is defined from minus infinity to the 2. Minus infinity to the 2. And this part is defined from 2 to the positive infinity. Therefore, the domain is all real numbers. But if we take a lowest point here, when x is 1, and find y, you can see y is minus 1. Here began the function and going up. to the positive infinity. That means the range is from -1 to the positive infinity. Example number 5. Find the domain and the range of the function f(x) equal x minus 1 square minus 1 when -2 less than and equal x and less than 3, and minus x plus 1 when 3 is less than and equal to x and less than 5. If we draw the graph of the function, it be like this. We can see that the function is defined at interval -2, 3, when n3 is open and n -2 is closed, because here we have an equal. And then the function is defined in another interval, which is 3 to the 5, when n3 is closed and n5 is open. If we united these two intervals, then the domain of the function it be from -2 to the 5, when in -2 is closed and in 5 is open. As it is clear in graph, the value of the function starts from -4 to -2 and from -1 to 8. Or you can get, if you replace it -2 in x minus 1 square minus 1, you can see that the value of function is 8. And if you replace it 3 here, you can see that -3 plus 2 is -2. Then the function is defined here. And if we replace it 5 here, you can see that -5 plus 1 is -4 here. That means the value of function is from -4 to -1 and from -1 to the 8. We get here a lowest point when x is 1. We get that the value of y is -1. Therefore, the range is from -4 to -2 and from -1 to 8, where in -4 is open and in 2, -2 and -1 and 8 is closed. Example number 6. Which interval below is the range of the function x squared plus 2 and absolute value of 2? Here, whatever the value of x is negative, the value of x squared plus 2 is positive. That means is bigger than 0. And whatever the value of x bigger or equal to the 0, the value of absolute value of x minus 2 is bigger or equal to the 0. Therefore, the range is from 0 to the positive infinity. That means C is correct. Since function is defined at x less than 0 and x bigger or equal to 0, therefore the domain is all real number. And when x is less than 0, x squared plus 2 is bigger than 0. When x is bigger or equal to 0, then absolute value of x minus 2 is bigger or equal to 0. You can take a number for each interval and replace it in place of x to be sure in this solution. Then the range is from 0 to the positive infinity, as you can see in the graph of the function. Domain and range of the function sine x and cosine x. Function sine x and function cosine x, if we draw the graph of them, this is the graph of the sine and this is the graph of the cosine. As we can see that the sine is defined it at all value of x. That means the domain is all real number and starts from -1 going up to 1 and coming down to -1 going up to 1, continuing in this way. That means the range is from -1 to 1. The cosine x is start from -1 to 1, then from 1 to -1, from -1 to 1, continuing in this way. Domain is all real number and the range is from -1 to 1. Be careful, the domain of the sine or cosine function is the domain of the angle. But if sine or cosine multiplied it with a number, then the interval -1, 1, which is represent the range, multiplying by the same number to find the range. Example number 7. Find the domain and the range of the function fx equal sine pi x. Because the angle of the sine is a polynomial function, therefore the domain is all real numbers. Because we haven't any number multiplied by sine, therefore the range is from -1 to 1. Here you can see starting from -1 to the 1, coming down to -1, going up to 1, continuing in this way. Therefore domain is from -infinity to positive infinity and the range from -1 to 1. Find the domain and the range of the function fx equal to cosine pi x. As we said in previous example, because pi x and a polynomial function, therefore domain is all real number. But because we have multiplied it cosine by 2, therefore the interval -1, 1 multiplying by 2, therefore range is equal -2, 2. If we draw the graph of this function, you can see that start from -2 going up to 2, they're coming down to -2, going up to 2, coming down to -2, continuing in this way. That means the domain is all real number and the range is from -2 to 2. Example number 9. Find the domain and the range of the function fx equal 1 over 2 sine pi x minus 2. Pi x minus 2 is an polynomial function, therefore the domain is all real number. And the range, because we have multiplied its sign by 1 over 2, therefore multiply the interval -1, 1 by 1 over 2. That is become from -1 over 2 to the -1 over 2. If you draw the graph, you can see that the function starts from 1 over 2, coming down to -1 over 2, going up to the 1 over 2, coming down to the -1 over 2, etc. That means the domain is all real number and range is from -1 to 2. Domain and the range of the fx equal tangent x. To find the domain of the tangent function, solve the equation angle not equal pi over 2 plus n pi. Then domain is equal to the solution. X not equal pi over 2 plus n pi because we have an angle is x. Therefore, the domain is all x when x is not equal pi over 2 plus n pi, when n is an integer number. As you can see here, the graph of the function tangent x coming from minus infinity going up to the positive infinity, and you have the vertical asymptote when x is minus 3 pi over 2 and minus pi over 2 and pi over 2 and 3 pi over 2. These are all vertical asymptote, but the range is all real number. Find the domain and the range of the function fx equal tangent to x. Now you have an angle is 2x. Take 2x is not equal pi over 2 plus n pi and divide both sides by 2. Therefore, x is not equal pi over 2 plus n pi divided by 2. Therefore, x not equal pi plus 2n pi over 4. Then the domain is all x when x is not equal pi over 2n pi over when n is belong to the integer number. You can see here the graph of the function. The x is equal pi over 2n pi x are the asymptote, vertical asymptote. The domain is x when x is not equal pi over 2n pi over 4, but the range remain r. Example number 12. Find the domain and the range of the function fx equal tangent pi x. Here we have the angle is pi x. Take pi x not equal pi over 2 plus n pi, dividing by pi, then x is not equal 1 over 2 plus n. As you can see that the domain of this function is all x when x is not equal 1 over 2 plus n. These are a vertical asymptote. Find the domain and the range of the function fx equal tan 3 pi over 2x. Take 3 pi over 2x and not equal to the pi over 2 plus n pi. Multiplying both sides by 2 over 3 pi, it becomes x equal 1 plus 2n over 3. As you can see here, these are an vertical asymptote. Domain is all real number x when x is not equal 1 plus 2n over 3 for n belong to integers, but the range remain all real number. Find the domain and the range of the function fx equal 1 over tangent x. We have two cases in this example. First one, tangent not equal to 0. fx it be defined when tangent is not equal to 0. Tangent is sine over cosine, therefore must sine not be equal to 0. When sine x not equal to 0, then x is not equal n pi. These are an vertical asymptote. Here, when n is minus 2, therefore x is not equal to minus 2 pi. That means here the function is not defined. When n is minus 1, then x is not equal minus pi. That means here is not defined. When n is 0, therefore x is not equal to 0. Therefore n0 is not defined. When n is 1, therefore x is not equal pi. Here is not defined. When n is 2, then x not equal to pi. It is not defined. You can see that in minus 2 pi and minus pi and 0 and pi and 2 pi have a vertical asymptote. But we take another probability. Tangent x equals sine x over cosine x is defined. Tangent is defined when cosine is not equal to 0. Therefore x is not equal pi over 2 plus n pi. If we take a value for n, we can see that in minus 3 pi over 2 the function is not defined. In minus pi over 2 function is not defined. In pi over 2 function is not defined. In 3 pi over 2 function is not defined, continuing in this way. That means in minus 2 pi and minus 3 pi over 2 and minus pi over 2 the function is not defined. That means the domain is all x when x is not equal n pi over 2. N pi over 2 is coming from the intersection of these two intervals, x not equal n pi and x is not equal pi over 2 n pi. And the range is all real number except 0. Find the domain and the range of the function fx equal 1 over sine x. This function fx is equal 1 over sine x when is defined when sine x is not equal to 0. Sine x is equal to 0 when x is equal n pi. That means sine x is not equal to 0 when x is not equal n pi, when n is an integer number. Therefore, the function is not defined at minus 2 pi, minus pi, 0, pi, and 2 pi. That means the domain is all x when x is not equal to n pi, when n is an integer number. The range of this function starts from minus infinity to minus 1 and from 1 to the positive infinity. Or we can say all real number except open interval minus 1, 1. X equal n pi are an vertical asymptote. Here we came to the end of the video. Please share it with your friends so that everyone get benefit. Please write your comment and subscribe the page to encourage us. Also, please like and ring the bell. Thank you for watching and goodbye.